Welcome to Interface Studies. My name is Saleh. There's a corner on the internet called Unix porn. It is full of genuinely striking screenshots of Linux desktops that look nothing like any computer most people have ever used. Terminals arranged in geometric grids with no title bars, status bars showing CPU load, battery percentage, and current song. Color schemes derived from a single wallpaper image. Setups that took months of work. People document them, share their config files and videos, and iterate on them publicly. The reaction most people have on first encountering this community is somewhere between admiration and incomprehension. Admiration because it is clearly skilled, clearly deliberate, and often beautiful work. Incomprehension because why? Why spend that much effort on the appearance and behavior of a screen? Why does this exist at all? The answer is way beyond the aesthetic vanity. It is that people have discovered something the rest of computing actively conceals. And it is that the screen is not fixed. What we see on our computers today is a design decision made by specific people in specific circumstances. It was then locked in place and handed to everyone else as the only possible option. The story of the floating window model is a bit more complicated than it seems, but the general narrative is that it started at Xerox PARC in the late 70s as a metaphor for a physical desk. In a floating window model, applications appear as overlapping rectangles you drag by a title bar, managed by a mouse, sitting on a virtual desktop. Things sit in front of or behind each other. Apple took this model and built Lisa and the Macintosh later. It was very successful. Microsoft copied it for Windows. Each generation refined the visual details but left the underlying logic entirely intact. Linux as well has the same thing, but it was slightly different, as we're going to see in a bit. The question this model was answering was, how should a screen organize running software? It wasn't answered definitely. It was answered once, successfully enough to propagate, and then the question was quietly retired. Today, on macOS, Windows, and most Linux distributions that target mainstream users, the window manager is buried inside the operating system, invisible and unchosen. You did not decide that Windows should float and overlap. It was decided for you long before you sat down. Now, when it comes to Linux and what makes it different is a single architectural choice made in 1984. The X Window system was built on a deliberate refusal to dictate how Windows should be managed. It provided the infrastructure for drawing pixels and handling input, then said nothing else. This specific decision allowed a great deal of experimentation. Experimentation on a user interface level. Ideas were tried and discarded without being wired into the Windows system itself. The window manager was a separate, swappable program. Anyone could replace the existing one. The question there remained open. So, what is a window manager then? The window manager is the program that decides where the applications appear on screen, how large they are, whether they have title bars, and which ones receive your input when you click. The part of the system that decides how things should behave rather than just enabling behavior. Under X11 on Linux, the window manager was a separate process talking to the X server. It could crash and restart without killing your applications. Early on, the compositor was an optional extra layer that took finished window images from X and combined them into the final frame, mostly to enable effects like translucency and drop shadows, while the X server and window manager still handled most of the logic. Later on, Wayland replaces the X11 protocol with one where the display server is typically a compositor that also implements window management policy. So on Linux today, most systems combine window manager and compositor into a single program. That compositor is now the central authority for rendering input layout, and most of the security policy. This is the model used by different modern compositors like Hyberland, Neri, and GNOME Mutter. Libraries like WL Roots, written in C, and Smith A, written in Rust, both of which you can find on GitHub, provide shared plumbing for building such compositors. And I was talking about all this because this is quite important, because it cuts the effort of creating a new Wayland desktop from years of work down to months for a single developer. On macOS and Windows, things are different. Everything is fused together. Quartz Compositor on macOS and Desktop Window Manager on Windows both act as always-on compositing display servers. The difference is that on Linux, you can replace the whole thing. On macOS and Windows, you cannot. Now, because of this openness on Linux, the spectrum of what people have built is not a catalog of preferences. It is a set of competing claims about what computing is for. We can start with the familiar, which is stacking. It is the model we already know. Windows float freely, overlap, and are managed by hand. It is the desk metaphor implemented faithfully. GNOME and KDE Plasma and macOS and Windows, all of them, despite their surface differences, share this spatial assumption entirely. Tiling rejects that desktop metaphor completely. Rather than windows floating freely, the screen is partitioned into non-overlapping regions that applications fill completely. Open a second application and the screen divides. Open a third and it divides again. The window manager handles placement automatically. No dragging, and navigation moves completely to the keyboard. Now, tiling itself as an interface concept was not new and was not because of Linux. An example of it was shown during Douglas Engelbart's famous demo. i3, released in 2009, still dominant in the Linux tiling community, lets you split panes horizontally or vertically and building a tree of nested regions. Hyperland adds smooth animations and has become one of the most widely used compositors outside mainstream desktop environments. What tiling actually changes is what you spend your attention on. The floating desktop imposes a continuous low-level task, like resizing, repositioning, hunting through a taskbar, or deciding where a new window should go. These actions are habitual enough to be invisible, but they accumulate. In a tiling system, that cost largely disappears because the system has an opinion, and the opinion is usually more useful than the open-ended freedom of floating. Tiling is usually very popular with developers, for example. Scrollable tiling challenges an assumption even conventional tiling makes, that the screen's edge is the workspace edge. In Neri, which is also available on GitHub, windows are arranged in columns on an infinite horizontal strip. Opening a new window never causes existing windows to resize. The workspace extends as far as your work requires, and you scroll through it as you scroll through a document. Having an unlimited number of windows on a desktop makes them collections of topics rather than multiple desktops bounded by what fits comfortably on screen. And because of this flexible architecture, we are starting to see entirely new ideas. WM, which is a spatial compositor, is an early example. Again, open source and available for everyone to build. Windows on it exist on an unbounded two-dimensional plane. The screen is a viewport you navigate by panning and zooming with trackpad gestures. Windows have absolute coordinates on that plane. Proximity carries meaning here, and the spatial logic is not imposed by an algorithm but constructed by you, organically as your work accumulates. It is not floating and it is not tiling. It is a spatial metaphor closer to a whiteboard than a desk or a grid. What all the work in these communities makes visible is that choosing between these models is not a technical preference like choosing a text editor. It is almost a statement about what a computer is for and how attention should be organized in front of it. The setups people share are not just decorative, though many of them are also that. There's nothing wrong with that as well. These setups are functional philosophies made visible. The months of refinement are not vanity. They are what happens when someone is optimizing not for a common dominator, but for their own specific way of thinking and how they see their computer. It makes the computer and the operating system itself almost feel like an intimate object. Now, not everything on Linux is wild and free. GNOME Shell, which is the default on Fedora, Ubuntu, and most enterprise Linux, is the opposite of this. Everything there is coherent, polished, and deliberately settled. Its compositor, Mutter, implements the floating model. The whole environment, which is the window manager, the launcher, notifications, settings, is a unified whole in which the policy assumptions are not exposed and cannot be changed from underneath. You can install extensions that add tiling behavior, for example. You cannot replace the spatial assumption those extensions sit on top of. Back to macOS and Windows, which are identical in this respect. But this unmet demand created an effect that is a growing market of apps around it. On macOS, we can see apps like Rectangle, Magnet, Moom, and many others, and their purpose is just to offer new ways of arranging windows, or at least offering that option. Apple added a form of tiling only in macOS Sequoia in 2024, 4 decades after the desktop metaphor was established. On Windows, we have something similar, which is Fancy Zones, available on PowerToys, which is a supplementary toolkit provided to Windows users. Windows 11 also supports a form of tiling. But what we see in the tiling window manager on Linux, or even the scrolling tiling features on other versions, is a completely different way of looking at it. And it's usually way more open for control than everything else available on macOS or Windows. We have two competing models here. One, which is represented by macOS and Windows, tries to put new features on top of existing ones without fundamentally changing the metaphor. They're almost stuck with it. What the openness of Linux allowed is a complete exploration of what this space actually is, including completely ripping apart the basic concept of a desktop, which was originally inspired by a physical object anyway. And that thing on Linux created tiling, scrollable tiling, and infinite spatial planes, and whatever comes next. On top of that, the ability to shape everything the way you want, and the argument becomes clearer. That's the other model. This is not just about personal preference. It is a demonstration that something else can be done. What we have been accustomed to, or in many cases simply handed over, is not the only answer. This is what takes us to the age of AI now. The AI features arriving on commercial operating systems in 2025 and now in 2026 share a consistent architectural position. They all sit above the window manager, not inside of it. Microsoft Copilot integrates into the Windows taskbar as a task automation layer. Apple Intelligence, which we're still waiting for its final form, currently summarizes content and generates text. Google's upcoming Aluminum OS describes itself as built with AI at the core. Yet some leaked footage shows a conventional floating interface, its most notable changes being a taller taskbar and repositioned status indicators. And of course, Gemini operating as an assistant above the surface. In each case, AI is added on top of the window manager. The spatial logic of the screen is not touched. This may be a direct consequence of the locked architecture. It worked well for a very long time and shaped how people think about computers. But now things are changing. When the window manager's assumptions are fixed and not exposed as variables, AI can only be added as an assistant, like a conversational interface in the corner or an agent that helps you manage your files or schedule meetings. And in its most capable way, it can control the interface itself, controls the mouse, and perhaps fill in a spreadsheet. What it structurally cannot do is alter how the screen itself works, because that is not a parameter the system exposes. On Linux, it is. The Open Compositor architecture, which is the same that produced tiling and scrollable tiling and all of that, is the precondition for something that does not yet exist, but is now technically conceivable. A window manager that learns, for example. Not only that adds AI as a feature, but one in which the policy layer itself is adaptive, observing which applications you open together, in what sequence, and approaching them accordingly without requiring you to specify a layout or switch a mode. That was just an idea. There's something deeper here than just smarter window placement. The nature of agents and AI now is already beginning to resurface a much older question. How should a computer be used at all? If an agent can act automatically across applications, like navigating interfaces, executing tasks, managing context across tools, then the entire assumption that a human needs to see and manage individual windows starts to shift. We designed the screen around human attention. We built the desktop for a person who would look at it, click on things, and move things around. If that person is increasingly delegating to a system that doesn't need to look at anything, then the window manager, every model of it, floating or tiled or spatial, was built for a mode of computing that may itself be in question. The Linux window manager ecosystem spent 40 years asking what the best screen for a human looks like. AI is beginning to ask whether the screen, in its current form, is the right interface at all. There's a real opportunity here, but this is a different topic for a different time. After all this history of using operating systems and computers, most users of commercial desktops have never been told any of these questions exist. They were given an answer, and that answer has been maintained so successfully that it no longer presents itself as an answer at all. It presents itself as simply a computer. What the Linux window manager ecosystem represents in its entirety, from the tiling grids to the infinite canvases to the months long refinement of a color scheme on a Reddit community, is the insistence that the screen is an argument, not a fact. That the way we have organized software on a rectangle of glass is one choice among many, made contingent by history and calcified by commerce. The question of what a computer should look like and what it should feel like to use one has never been settled. We're now at a completely different era of computing where this question is surfacing in a very aggressive way, but it hasn't been completely forgotten. It has only been forgotten on commercial computing platforms. And the people building and sharing and iterating in these communities, they did not forget.